If you see an equation like this and you have to find the derivative, you might immediately think that you have to use the quotient rule, but there's a much easier way. And first I'm going to simplify it, and then I'm going to differentiate. Okay, I'm going to rationalize the denominator. As you know, there are several ways to go about doing this. I went ahead and put it in fractional exponent form. And the x to the 1/2 is the same as the square root of x. And we wind up with 3x to the 5/2 minus 2x to the 3/2 after we over x after we expand. And I'm going to go ahead and cancel. So I'm going to cancel this x. The index or exponent was 1, so I just made it 2/2 to make canceling easier. I'm going to cancel out 1x from this term and this term. Okay, now we're ready to find the derivative. And remember, when you find the derivative, which in this instance we're using this notation, so g prime of x is equal to, use the index, multiply it by the coefficient, and then subtract 1 from the index or exponent. I'm going to multiply 3/2 times the 3, which is the coefficient, and I'm going to subtract 1 from the exponent. So I'm going to subtract 2/2, so I get x to the 1/2. Okay, minus, now multiply 1/2 by the 2 times 1/2 is 2/2. Now I'm going to subtract 1, so I'm going to subtract 2/2 from 1/2, and I get negative 1/2. And now here is what I have. Some books will leave it at that, but I'm not going to. I'm going to put it in the simplest form. And as you know, you should never leave a negative index. So 9/2 x to the 1/2 minus 1 over x to the 1/2. And we're finished.